An access modifier in C# specifies who can see and use a resource. You're probably familiar with the public and private modifiers. We use those a lot, but did you know there are others? In this video, I'm going to cover 6 different access modifiers and when you'd use each. We're also going to discuss why we have the various modifiers, and it isn't just about security. If you're new to this channel, my name is Tim Corey, and it's my goal to make learning C# easier. This channel is full of videos explaining the various parts of C#. I also have a website where I provide full courses on C# and SQL. Now, one of the things I encourage is for you to practice what you've learned in a real-world application. As of the recording of this video, I have 2 different start-to-finish courses that do just that, and more are on their way. If you want to see how the various things you learn fit together in a real application, check out those courses. Now let's get started in our example project. As with all of my recent videos, I have uploaded the source code as part of a blog post on the subject. Be sure to follow a link in the description to get the code. Now what we have here is a really simple application to set up just to show us how these modifiers work. Okay, so we have a console user interface and we have a demo library. The demo library is a class library. These are both .NET and .NET Framework, And this access modifiers is where we're going to show off the various levels. And so I've created the various levels to start us off so we can kind of see where everything lives. All right. So we have a private demo, a private protected demo, a protected demo, and so on and so forth. And notice these names refer to what their access modifier is. Okay, so the private demo specifies it's a private method. All right, so let's talk through each of these modifiers, and these are all the ones we're going to cover today. We're going to talk through each of them and who can see them and who can use them. So we're going to start off at the very top with private. So private is only accessible in the area it was declared. So think of this as the curly brace boundary. So this private demo was declared inside of these curly braces. Okay, all the way down to here, which is the public class access demo. Therefore, the only things that can call the private demo are other items in this class. Okay, so let's demonstrate that. So if I were to say, let's just create another private void demo. So this is just our demo caller. This is going to be what you use to try out various things. And I could say private demo. Notice it showed up in IntelliSense. Maybe I did it too quick for you. It shows up in IntelliSense. I can see it. I can use it in this method. Okay, so private demo is accessible to demo. Now, if we came over here to console UI and add a reference to our project demo library, that should allow us to, in program.cs, view or use some of those things. So let's add a using statement up here for using demo library. Okay, so now I should be able to say demo library, let's create an instance of it. D equals, let's call it demo, equals new demo library. Demo, and it's yelling at me. Oops, it's access demo. There we go. I was reading my using statement instead of my project name instead. So demo dot, now notice you don't see that private demo. You see these 4 equals get hashcode, get type, and toString, which are part of any object. And you see public demo, and that's it. Okay? So what that tells us is that we cannot call the private demo method from a different project or from a different assembly. So that's the far reaches, but let's try this. Let's create a new class inside of our library itself, new class, and we'll call this the calling demo class, okay? And just because we normally do it, make it public, but then we're going to have a private void in here called make demo calls. And here we'll try saying access demo demo equals new access demo and demo dot. And notice we still don't have that private demo listed, but we have a few more. So we have our equals, get hashcode, get type, and toString. Those are part of the standard object. But now we have internal demo, protected internal demo, and public demo. So we have those three, which program.cs only had one, but we still don't have private. And that's because private only lives inside these curly braces right here for access demo. No one outside that can call private demo directly. Okay, now just to be clear here, I said directly because if we know that public demo works, okay, because we've seen public demo here and we've seen public demo over here. So if I were to put in public demo a call to private demo, that would work because public demo has access to private demo, whereas these others do not. So it's directly. These two, program.cs in the console UI and also the calling demos class, neither of them can access private demo. So that's the easy one. We've kind of gotten familiar with that, but I just want to make sure that I cover that so that we start off with a good foundation. Now let's move on to others. Okay, I'm going to kind of bounce around a little bit. I want to keep the naming close. So we have, private, protected, and then protected. So I want to keep those close. But let's skip down now to the next one I want to cover, which is internal. So right down here we have internal. This one is a little bit broader in scope, but you can still think of it kind of like the private. Okay? So what internal does is it says, instead of my scope being the curly braces I was declared in, it says my scope is the entire object I was declared in. Now you may read of this in documentation as the assembly. So what that just means is the project. Okay, because a project creates an assembly, each project. So the demo library, which is a class library, creates a DLL. That's an assembly. Console UI creates an executable, an exe file. That's an assembly. Okay, so this right here is the level at which internal can be accessed. So, for example, in the calling demos, if I were to say demo dot, notice internal demo. So this has access to the internal demo because it is inside the same assembly, the demo library. But if we go over here to program.cs, which is in the console UI, if I say demo, I do not see internal because internal only works in the demo library. Now, before we go too far forward, I want to mention that I will come back around and we'll talk about different times or places these might be useful and why you use them overall. But I will mention here and there some ideas or some thoughts on what could be used and when. And, so for internal, this is for stuff that you want to have accessible for everybody in your DLL especially, is typically what it is. Think of these as helper methods. Methods that you might want to have in more than one class or available in more than one class, but you don't want them exposed outside of your DLL. So that's where you use internal. Okay, so that's internal. Internal works anywhere inside the same assembly, but nothing outside the assembly. And let's go to the easy one, the one we've used a lot, but I want to make sure I cover it, and that is public. So public is accessible everywhere. Pretty much, if it says public, anybody can talk to it. So if I go to calling demo, and you see that public is one of the options. If I go to program.cs and go to demo here, the public demo is accessible here as well. So public basically means anybody can talk to me. It doesn't matter if you're in the same assembly or a different assembly. If you reference me, you can talk to me. So that's a very, very common one for us to do because especially in DLLs, we want to have exposed some methods that other projects can use. You know, think of these as the common library that everybody uses. Well, they have to have public on them because other things have to use them. All right, so that's a pretty simple one. So you have public, we have internal, which is at the assembly level, and we have private, which is at the declaration level, basically in this case, the class. Now, I am talking about methods right now, and so it does change a little bit when we're talking about other things. So there are, you can do private variables and you can do internal variables and all the rest. But in this case, we're focused primarily on just the access modifiers. And so, in this case, in private, I'm pointing out here, it's curly brace level, because if I were to declare this private, whoops, wrong level. If I were to declare it up here at this class, I'd say private int test. That also works the same way as the private method. Okay, the same would be with a property. So this would be a field or a variable, a property. You can do events and all the rest. So, but I'm more focused on the modifiers, just so we're clear on that. How they are applied to different objects is pretty much the same way. Some objects can't have certain modifiers. For example, in an interface, you can't have a private anything. It's just, there is no modifier because everything is public. So there are some edge cases here, but really what we're talking about is the modifier itself. So let's talk about the last single word modifier we have, and that is protected. Now, you probably don't see this a lot, and there's a reason for it. And the reason for it is because we don't typically do a lot of inheritance. But this is something that's used a lot in inheritance. So if you see inheritance going on a lot, you'll probably see protected. So what protected means is that you can access it in this access demo class because that's where it's declared. So the curly braces apply here. Or in any method inside of a class where you were derived from this class. So let's clear that up a little bit. So if I were to create a class, let's create a class right here and say inherit from access demo. Okay, long name, but that's okay because it's more descriptive of what we're trying to do. So we're going to inherit from access demo. Okay, so now just to be clear here, this is protected. If I went to calling demo and looked for protected, I don't see protected. I see protected internal. That's different. So I don't see protected. So that's even in the same assembly. And of course, we don't see it over here. We only saw the public one, so it's definitely not there. But if I create a method now inside my inherit from access demo, and I said public void test, and I said, let's create a protected demo. Let's call that. No problem. I can do that. Now, just to show you the other thing I can't do, let's try the internal demo. Yep, I can do that. Let's try the private demo. And no, I cannot. I can do private protected, but not private. So, and of course, public would work. So protected allows me to call it from the class it was declared in, okay, which would be access demo. That's the curly brace rule. Or from any class that inherits from this class. So in this case, this class inherits from access demo. So therefore, it has then access to call the private methods of access demo. I'm sorry, the protected methods of access demo. That can be really useful when you're talking about building something where you have these little helper methods that you can use in those inherited objects, and you don't want to make them public. You don't want to make them accessible to anybody outside of the class or the inheriting class. Okay, so if this were employee and this were, let's just say janitor, I'm not sure. So janitor probably uses some of the helper methods the employee would use. And so it could have access to those if they were protected instead of private. Okay, so think of it as private except to those that I inherit from, in which case then they're available as well. So a little bit more tricky there, but there's definitely some use cases in inheritance. Okay, so now I have two more, and let's talk about both the private protected and private internal. Let's start with the one we just covered. Let's go private protected. And this one's kind of fun. So these modifiers are really neat because they allow us to scope things out just how we need. So private protected says that it is available in access demo. Okay. If we come over here to calling demo and go here, we can see it's not available here. So it's not available in calling demo, so it won't be available in program.cs either. And let's check over here. Private protected. So it's available here in inherited from access demo. So it seems like it's scoped the same way. But there's a difference here. And this is something I didn't show you for protected, but we're going to go over it now because it does show the difference. Let's go to console UI and create a new class. And we're going to call this class inheritance demo. And we're going to inherit from access demo. We'll have to add a using statement here. And we'll add our method demo. So private void demo. Now, we can call protected demo, which is our method inside of the access demo class that's protected. Okay, which makes sense because we can inherit. Since we're inheriting from access demo, we have access to protected methods. But notice what we don't have access to. There's no private protected. Okay? Because the difference is that even though we can access it over here, we can't access it over here. The difference is which assembly it's in. So we can access private protected methods inside the same assembly, so demo library, but not outside of it. So it's private if it's outside the assembly. If it's inside the assembly, it's protected. All right, so you see how these different boundaries are being drawn? There's a boundary for each circumstance you need. Now, some of these are really edge cases. They're not something you use every day. And so I'd encourage you to, practice these things and try them out so you understand how they work. Maybe document them for yourself in your terminology so you can understand them. And then keep in the back of your mind. But then when you're working on code, default to private. And then if you need something that's available for anybody, make it public. But then those other cases, you have these really surgical, precise things you can use to fit the permissions you need. So let's get rid of this code since we don't have the ability to access that. Let's go back over here and look at one last one, which is protected internal. Okay? So protected internal is a little bit different. Let's see where we can use it. We can talk through and kind of show you how it works. So if we go over here to calling demo, protected internal is available. Cool. So we have access to it from a different class inside the same assembly. We know we don't have access to it in program.cs. Okay. Now, if we came over here to inherit from access demo and go protected internal, we have access to it here. Okay. Now let's go over to inheritance demo and say protected internal. We have access to it there as well. So we have access to it inside the same assembly and also from wherever it inherits. So basically, this is protected inside its own assembly, and it is internal inside of any class that inherits from it. Okay? So it's accessible everywhere in demo library, and it's accessible inside of inheritance demo class. All right? So those are the 6 types. Public is available everywhere. Okay? Then we have the least available, which is private, which is only inside the same class or object it was declared in. Then we have protected, which is inside of the class it was created in or inside of anything that derives from that class. So in this case, here, so there's our protected. Internal works anywhere inside the same assembly. And then we have protected internal, which means it works inside of this demo library assembly and wherever it inherits from. So in this case, inheritance demo. And we have private protected, which is only available inside the class that declared it, as well as from the class that inherits from it, but only in the same assembly. Okay? So there's our map of the 6 different types of modifiers. Now, here's my personal view on what I have seen. Typically, the most common, as you probably know, are public and private. Public, because we have these libraries that other objects or other projects need to call. Therefore, we have public methods so they can call it. So program.cs can say, run this method. Okay, so that's public. That's what we use a lot. We use private a lot so we can make a helper method or something small that wouldn't necessarily be used outside of this the class we're using it. So for example, let's just actually make this work so we can get rid of the error. I might have here a private static void say hello method that just says hello user. Okay, that would be not say hello. So that might be used internally to kind of break up my code and have every method do one thing. So I can use it more than once. I might say hello more than once, but I only really use it in this class. It's not really useful outside this class. Therefore, private. So those two are the most common. But the one that I see not used, but I think should be used a lot more, is internal. So the reason for internal is for a class library especially, okay? And for helper methods. or methods that are common across more than one class. So think of this in terms of dry. Don't repeat yourself. And I use dry an awful lot because it's one of the most simple and yet most powerful things a developer needs to learn, is not to repeat yourself. And so if you're writing the same code more than once, you should probably think about creating some sort of method or something to allow you to use it more than one time, but only have it written once. So in this case, if we had the internal demo, maybe this is code that everybody uses, okay? Let's just think of it as a calculation. Maybe there's a calculation we have to use in multiple classes. Think add, okay? Well, I only want to write it once. Maybe I create a helper class and put in there the add method and make it internal because console UI doesn't need to see it, okay? But it's helpful for 2 or more classes inside of demo library. So therefore, we're not clogging up our publicly exposed methods, but we have this helper available inside all of demo library. That's the one that I think that people miss often. It's the one that is just kind of overlooked. And so what happens is they say, oh man, I need to have this add method in 2 different classes. Well, I don't make it public because that makes no sense to have this add method hanging out there. Therefore, make it private and just copy and paste it. That's, red flags should be going off somewhere. Okay? That's a much more common use for internal. Now, protected, if you're doing class inheritance, which isn't nearly as common as people think it would be in object-oriented language. But if you're doing inheritance, then protected is a very common one because it allows you, again, to use those helper methods in other inherited classes. The other 2, the combination ones, private protected and protected internal, these 2 are more like mixes. I mean, obviously they say protected internal is 2 different things. So they're mixes that help us cover some edge cases where maybe we want to have this helper method available in inherited classes and we want to have available inside the demo library assembly. Well, that would be from before protected internal. Okay, protected internal covers that. We can access it anywhere in demo library and anything else it inherits from the class it was declared in. That's kind of useful sometimes. Again, small cases, but put it in your library of things to use when necessary, because you might be tempted to repeat yourself where you have an internal helper method and you go, oop, I actually want to have access to it from inside this, but it's inside console, so let's recreate it. Again, warning flags. Think about changing your modifiers. Okay? Private protected. Private protected is more about protecting things. Makes sense, right? Protected. Protecting things and go outside the boundary of your assembly. There's some methods that you create that just shouldn't go outside of your DLL or your whatever you're creating. And so some of those things might be things where they do part of a job, okay? A method should have one job, but in the real world, a job is really a bunch of jobs put together, okay? A pretty simple one. You go to a bank and you give a check to the cashier and say, I would like this cashed. Or let's put it in my account. Put this check in my account. Well, they don't just do one task there. What they're doing is they're contacting the other bank and they're saying, do you have the funds for this? If you do, transfer them out of this account. And then they're transferring those funds into your account. Now that's a bunch of tasks put together as one larger task. So imagine for a minute that you had a method called deposit funds. Okay? Because it does one thing. It puts money into an account. So you pass an account number and an amount. and it puts that amount into the account number. That's great, and that can be really useful in more than one spot in our assembly, our demo library. But imagine for a minute if I had access to it at program.cs. Well, I could say, hey, you know what? Let's deposit funds, $56. Maybe I'm thinking I'm depositing a check. But the reality is I never withdrew funds, which is part of that larger task. I never withdrew funds from somewhere else. I just created that money and put it in my account, which sounds great. But you have to have withdrawal somewhere else. So those little helper methods are great, and they are self-contained so that you can use them in different ways, but you really can't use them independently. And that's where you wouldn't want to cross the demo library boundary. You want to say, yes, it's great to use internally, but you can't just have it available for anybody to call directly. Okay? Because even if it's not malicious, accidentally calling that method instead of the larger deposit check method, let's say, if you say deposit funds instead of deposit check, which may sound very similar, but deposit check is the larger task that breaks it down into different pieces. Deposit funds is just the one little piece that's putting money into an account. Okay? So that's why you'd want to have that private protected method. So that kind of brings up or kind of starts touching on, why do we have these different access modifiers? Why isn't everything public? Okay, let's talk about that. So the first reason why we don't just have everything public and available is so we can protect private information. Let's just say for a minute that, and let's create a bad class. I'm going to call it bad class because don't do this. Okay, so bad class. And I like the class public so you can see it. And we're going to make everything in here public. Let's make it property first. Nope. Let's make I'll make a property. Nope. First, we're going to make a variable. Public string SSN, Social Security number. Okay. If you're outside of the U.S., Social Security number is the government issued ID that each U.S. citizen gets that we have to keep private because let's make it easier. Instead of me trying to explain Social Security numbers and why they're a mess. Credit card number. I think everybody probably gets this. Okay. Credit card number. That's a private thing. We don't want to expose that. Well, I just made it public. So if I were in my main here, I could say bad class bad equals new bad class. I could say bad dot credit card number and get that. Okay? That's a security risk. Same with Social Security number, same with other private information. Typically, instead of doing this, what we would do is we'd make a full prop. Prop full, and we'd say it's a string. Let's call it Social Security number for this one. SSN. And instead of returning the full Social Security number, like so, we would return a partial. Let me just spoof this for now. Star dash 1 2 3 4. Okay? That's what it would do. It would take this number, it'd cut off the last four numbers and put that there and put stars for the previous ones. Okay? So it's storing the actual Social Security number, but it's only giving you back partial. Same thing with credit card number. We show the last four numbers, but we don't show the previous 12. Okay? That's the right way of doing it. But if everything is public, then it wouldn't matter that this is trying to filter out certain data and not show it. Think on a report or something like that. Instead, if we either accidentally or intentionally said, there we go. If we said underscore SSN instead of SSN, both of those look about right, and they actually both hold a Social Security number. It's just that this one will give you back or display only the last 4 digits. This one will display all the digits. Okay? Bad, good. That's access modifiers. Okay? So that's one thing. Now, I think I've also covered already that securing private methods is a good thing, or the security of private methods. Things like the deposit funds method I talked about, or delete user. That's a great method to have, delete user, in a certain context. But there's a larger picture we think about. Maybe that's just one step in the process of taking an employee out of the system. They've left. And so, yes, we delete the user from the Active Directory, but we also have to make sure we have their keys, make sure we have their exit interview, and all the rest of the things that have to happen as part of a larger task of, leaving employee or something like that, fired employee, whatever it is. Delete user is useful in both of those situations, where they're leaving or being fired, but it's not good on its own. Okay? So that's, again, security for those private methods. Now, that also brings up another thing which is close or similar but different, and that is it prevents bugs. Okay? These access modifiers prevent bugs. So let's just think we have a method called create Active Directory employee. Well, that's great, but did it also give them the permissions they need? No, because that's a different method. But because we created their Active Directory account, it looks like we have done the whole job, but that was one little piece. And so now you have a bug. We have a user with no permissions, and they come back to us and say, I can't log into this, I can't do that. Well, that's because we called the wrong method. Okay? Another one. Let's just say in our bad class, we had another prop. Oops. There we go. So this is going to be the age property. Now, when we set an age, we're going to be good citizens and not allow any age. We're going to say, let's Control X here, if value is greater than or equal to 0 and value is less than, let's go with 130. Then set the value. Okay? So that way, we only set the age value if they have a valid age. Okay? Now, yes, 0 is a valid age. Think of a newborn. They're not 1 yet. Okay? They're 0. We just don't call them 0. 130, I don't think anyone's lived that long. I think 120 somewhere is where any modern person has lived. I don't know about historical records, but that's probably about right. So that range, that's pretty good. Okay? That just gives us a close approximation. But if I come back over here to program.cs, oops, let's make it public because by default, it's private. Because Microsoft's trying to help us out and we're defying their wishes. Okay? So when I do bad, I can do bad.either age, the property, which is good. So I can say bad.age equals 150. That would work, but it would not put 150 into age. Okay? So it's going to do nothing essentially. But bad.age equals 150. That will put 150 in the age property because this is the private backing field. Well, I call it private backing field. It's actually now the public backing field. You should never have public backing fields. Okay? So this would quote unquote work, but it's not supposed to. It's introduced a bug into our system. It's bypassed our checks for valid data and just put data in anyways. Okay? So that's a problem. Now, the other thing that these modifiers allow us to do is they reduce the confusion and they reduce the options available to us. Kind of similar concepts there. Reducing the confusion and reducing the number of options we have when calling these outside of the class. So let's look at Access Demo for a minute and come up here to our demo. And let's look at what we have access to. So now we got a whole list here because of Microsoft. But I can say private demo. Let's just say demo. And let's look at, and it's not got filtered by it. We can say public demo. We can say private protected. We can say internal demo. It might be even easier if we did something like this. Access demo equals new. I'm actually declaring it inside of itself. Demo dot. Notice all the options we have. There we go. Much better. So we have access to, of course, this method. We can ignore that. And these three you can ignore. Then internal, ignore clone. Private protected internal, and public. Okay, and of course, toString is part of the standard. So you have access to a lot of things, and that's just with this little demo. However, if I go over to program.cs, and I were to say demo dot, I have my 4 standard, and then my 1 option. That's pretty clear to understand which ones I can call. Just public demo. I don't have the problem of which age to call. I don't have the problem of, is this part or the whole? I just have 1 option, public demo. Okay? Now, obviously, you'll have more than that, but it will only be the options that you really should and can use. So while security is important, and you should always be giving the least amount of permissions or visibility to your objects as possible, one of the benefits, the big benefit that people often overlook, is that it cleans up for us our instances. So demo dot only has the public things. When you're inside of calling demo, you only have access to things that are protected internal, or public. Okay? A little bit larger, but that's okay because you can use those. They're for you to use. What it doesn't include is the private stuff. The stuff that's only, that's set to private, that only Access Demo can use, and some of the other things. So this not only protects our code and protects our data from security breaches or from bugs or things like that, it also makes our code less confusing, and it provides us with just what we need to do our jobs and not a ton extra. This is really important when it comes to creating a full library. Now, this is a sample library. It's for a little application. But think about a library for a company, a larger company, that has hundreds and thousands of methods. You really only want to have accessible to you the things you should be able to use. Because if they expose their helper methods and their private methods and the things that are just kind of one-offs or things like that, if they expose all that, you would have tens of thousands or hundreds of thousands of things to look through that probably aren't named the greatest either. So by using these access modifiers correctly, you also make your job and the next person along the line make their job as well easier. So, to review, make things as private as possible, not the modifier, but the overall intent, okay? So keep things as small a window as possible. And these right here will allow you to dial it in to exactly where it needs to be. Private for anything you only want to have access to in the class that was declared. Public for anything you want to have available outside. But then the other ones will modify things appropriately to hit that middle balance in between. Okay? I hope you found this useful. I hope you found it clarifying maybe of some of the things maybe you missed as you grew up in development, or as you improved your knowledge of development, maybe you missed why you use all these different modifiers. My suggestion for you, and this is my suggestion for any time you learn something, is that you build 3 to 5 projects, separate projects that you kind of recreate every time. But little test projects that try out these different access modifiers. Don't just use my code. Create your own. Because creating your own not only allows you to test what you've learned, it also allows you to get more experience creating projects and wiring things up and doing references and using statements and all the rest of the stuff that you're just not going to get a benefit of if you just get a little bit lazy and use the pre-developed stuff. Because what happens is down the road, you have to do it for yourself and you don't have that depth of practice doing it. So practice 3 to 5 projects or so where you're trying out these different levels of security. Once you kind of understand them and use them and go, yeah, okay, I got that. Then start looking through your code and say, is there modifiers I need to change? Or, and this is even better, is there code I can refactor that will allow me to become more dry by not repeating myself here, where I could use an access modifier, maybe internal. That's a really popular one for refactoring. But where I can use this access modifier to scope this in such a way that it's available where it needs to be and not where it's not. Okay? So give it a shot. Let me know down in the comments if you have any questions about these modifiers or how your practice went. Okay? Until then, have a great day, and I am Tim Corey.